Hello. Today we're going to talk about how to make a box and whisker plot. And so first one is a box and whisker plot. Well, if you're looking over here at your screen, you see an example of one. A box and whisker plot is just a data display that organizes data values into 4 groups. Okay? So, and you should have seen box and whisker plots a little bit in 6th grade. So this should be somewhat of a review for you. So interpreting them. A box and whisker plot separates data into 4 sections or 4 groups. The 2 parts of the box and the whiskers. So you have the box. This is the box, which has a line in the middle. And then you have these lines coming out. These are called the whiskers. Hence the name box and whisker plot. You might also see it referred to as just a box plot. The great thing about a box and whisker plot is it says that all 4 sections contain the same number of data values. So each represent 25% of the data. So this represents from here to here is 25% of the data. From here to here is 25% of the data. From here to here is 25% of the data. And from here to here is another 25% of the data. Okay, now there are some arrows here that are pointing to different sections. And actually, we really need to erase some of these arrows. But since this is already printed, I want you to pull up a white marker and just trace over these arrows. And that'll be just as good as erasing them. Just the arrows, not the numbers. Don't worry about erasing that. Okay, so I've gotten rid of all the arrows. I'll get rid of that too. That looks a little bit better. Okay, now we're going to draw in our own arrows. So this, oops, let me change my pen size. So here's our box and whisker plot. It's usually drawn underneath a number line. Okay, the 264, which is the point that is furthest to the left, is called your lower extreme. That's this guy right here. It's the lower extreme. The lower extreme is the smallest data value. The point that is furthest to the right is called your, you guessed it, upper extreme. In this case, that's at 572. So you have a lower extreme and an upper extreme. Okay? And those make up the whiskers. Then you've got the box portion. Okay? And there are 3 points in that box portion. So this point right here is going to be called the lower quartile. And I'll explain what that means in a minute. So that, in this case, that's the 370. Now, sometimes we refer to it as first quartile. So you could see it referred to as the first quartile or the lower quartile. That 459, that's the other end of the box plot, or the box section rather, right here. This would be called the upper quartile. And again, sometimes you see this referred to as the third, not second. The third quartile. In a box and whisker plot, there's always a line in the middle of the box, or not in the middle, but inside of the box. It may be in the middle or it may not. It just depends. That line, which in this case is at 452, or that point, is the median of the data set. Okay? The median. So what are some definitions? Lower quartile, what does that really mean? The lower quartile is the median of the lower half of your data. And then the upper quartile would be the median of the upper half. We just said the lower extreme is the smallest data value, and the upper extreme is your greatest data value. Okay. So, when I look at this box plot, let me add just a couple more things here. When I look at this box plot, We said that it tells us some other stuff, right? So each section, and there are 4, represents 25% of the data values. So that from the 264 to the 370, that's 25%. From here to here is 25%. I don't know if y'all can see that line, but from there to there is 25%. And from here to here is 25%. So you could say 75% of the values are above 370. Like that's something you could say from this. Or 25% of the data values are above 459. You know, so there are some different conclusions that we can make from looking at a box plot. All right, so how do I go about making one? Well, first you have to put your data in order, typically from least to greatest. And you're doing that because you need to find your median. And remember, in order to find the median, the data must be in the order. So you find the median, put the data in order, find the median. Once you have your median, then you can find your quartiles, which are the medians of the lower and upper half of the data. Then you find your extremes. Well, if the data is in order, that'll be really easy to see. And then we plot our median, quartiles, and extremes. So there are 5 things that we plot below a number line, and then we draw in our box and whiskers. All right, so let's just do an example. So here we are, in this example, it says to create a box and whisker plot using the data. You've got 7, 19, 6, 12, 5, 17, 6, and 13. So step 1, we put the data in order. So I'm going to actually write that down here, data in order. Once we put the data in order, find the number that is in the middle. So in this case, there were 2 numbers in the middle, right? So you had to add the 7 and the 12. They were the 2 that are left in the middle. Then divide by 2. So our median is 9.5. So I'm going to write find median. That was the second thing that was done. Now that you've found the median, now we're going to find the quartiles. And they didn't do this one for you, right? So the median split the data into 2 pieces or 2 sections. So now I'm going to find the median of the lower half. Well, I'm left with 2 numbers in the middle, 6 and 6. So I'm going to do 6 plus 6 and then divide by 2. But you already know, right? That's going to be 6. So our lower quartile is 6. For the upper quartile, I'm left with 2 in the middle again. So I'm going to have to do 13 plus 17 and then divide by 2. Well, 13 plus 17 is 30, divided by 2 is 15. So there are my quartiles. And then the final thing that I need to do is I need to find the extremes. Remember, the lower extreme is the smallest number, which we know is 5, and the upper extreme is the largest number, which we know is 19. Okay, now that we've got all of that information, now we can make our box and whisker plot. So they've already made an arrow, a number line here for us. We see our data, remember, goes all the way from 5 to 19. So I'm going to put all of my data, or I'm going to put the numbers from 5 to 19 on this number line. And I can start, actually I'm going to start with 4, 5, 6, 7. And you want your numbers to be spaced out evenly. And actually, I didn't even use the whole number line. That's okay. So I'm going to just stop right there. All right, so I'm going to plot my extremes. So 5. So I'm going to put a dot above the number line, not on it. So there's my 5. And I need, my other extreme was 19. So there's a dot there. Then my quartiles were 6. So 6 gets 1. And what was my other quartile? 15. And then my median is 9.5. So that would be here. Okay, so you've got 5 dots. All right, the 3 in the middle are going to make your box portion. So I'm going to put vertical lines through those 3 and then connect them across the top. There's the box portion. Now you just got to do your whiskers. So just connect them out like this. That is the box and whisker plot for this data. Okay? So what I want you to do is I want you to try this next problem right here. It's not numbered. And then I want you to go to the next page, do the next 2 problems, and we'll do this last one together, okay? So pause the video and do the next 2 problems on your own. Hey guys, so you had an opportunity to practice making box plots on your own. So with this particular problem, notice that the median was not part of the data. So it was halfway between 12 and 13. And I know that halfway between 12 and 13 is 12.5. I could have added the 12 and 13 together and divided by 2. I'm still going to get 12.5. When I did the median of the lower half, I'm left with a 6 and the 9 in the middle. And halfway between 6 and 9 is 7.5. So that's where I just wrote first quartile, or first Q rather, instead of lower quartile, but they mean the same thing. So those 2 terms are interchangeable. Over here, I'm left with the 14 and the 17 in the middle, which ends up averaging out to 15.5. Okay, and then I've made my box plot accordingly. The next one looks like this. So in this case, the median was part of the data. So I'd build a wall around it. And when I'm doing the first quartile or lower quartile, I'm only looking from here to here. So the middle number there was 68. When I'm doing the upper quartile or third quartile, I'm going from here to here. So the middle there was 112. Okay. And then obviously I've drawn my box plot accordingly. And I just counted by 5s here and did that. All right. And then this bottom section, it says the box and whisker plot shows a class's test scores for 2 tests. What conclusions can we make? And these are all the different things that you can write about when you're comparing 2 box plots. So notice there's test 1 and test 2. So it says the blank are the same for both tests. So what is the same for both of them? Well, if you look right here, they both have the same upper extreme. So I'm going to write the upper extremes. Okay. Then it says the median for the second test is blank than the median for the first. So we're looking at these 2 amounts. Those are the medians. And they actually wrote the median underneath it. So the median for the second test is more or greater than the median for the first. So I'm going to write greater. Okay. The next one says the blank for the first test is the same as the blank for the second test. Well, one of the things I'm seeing right here is they both have 84s, but in the first test, that 84 is the, let's do it this way, that 84 is the upper quartile. In test number 2, it's the median. So the blank for the first test, the upper quartile, for the first test is the same as the median, we said, for the second test. All right, then it says, the next one, the scores for the blank are more spread out than the scores for the blank. So looking at the 2 tests, which test has scores that are more spread out? Well, if they both end here, we know that test number 1 is more spread out than test number 2. So the scores for the first test are more spread out than the scores for the second test. Okay, now range can be determined from a box plot because we can see the highest and lowest values, right? And then there's something called interquartile range, which I'll talk about that in a minute. So the range and the interquartile range of the first test are blank, then the range and interquartile range of the second test. So if I do the range of my first test, I'm doing 91, minus 62, which they've got written here. So 91 minus 62, let's see, 11 minus 2 is 9, and 8 minus 6 is 2. So the range would be 29. Now, interquartile range. When you do the interquartile range, you're taking the difference in the upper and lower quartiles, which in this case are 84 and 74. So that's a difference of 10. And let's go ahead and do the range and interquartile range for test number 2. So for test number 2, when I do the range, I'm going to do 91 minus 71, the biggest minus the smallest values. So that's 20. And then your interquartile ranges, so my quartiles here are 88 and 80. So when I subtract those, I get 8. So the range and interquartile range of the first test are blank, then the range and interquartile range of the second are more than. Now, there's a typo on this last line. It says inner. It should say interquartile. Let's erase that. Interquartile. It's one word. Interquartile range is the difference in the upper and lower quartiles. Okay, so that's it for this lesson. You're ready to move on now to the independent practice for today. If you have questions or need anything from me, be sure to bring it to my attention so I can help you. All right, good luck.